Day 273 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 373, find k-pairs with smallest sums. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now, let's see what the question says. Question says you are given a two integer array nums1 and nums2 sorted in non-decreasing order in an integer k. Define a pair of u and v which consists of one element from the first array and one element from the second array. Return the k pairs u1 and uv, u2 and u2 and u and v2. Excuse me, u1 and v1, u2 and v2, all the way up to uk and vk with the smallest sums. All right, y'all, sounds simple enough, but let's look at the examples just so we can know what it is that they want us to do exactly. So in example 1, we have the input nums equals an array of integers 1, 7, and 11. Nums 2 equals an array of integers 2, 4, and 6, and k equals 3. So that means we need to find three pairs. Since k equals 3, we need to find three pairs of elements that we can combine to get the smallest sum, right? From both of these arrays, we need to take one element from this array and one element from this array and try to come up with the three smallest sums that we can create. In this case, the output is a 2D array of integers, the first array being 1 and 2, second array being 1 and 4, third array being 1 and 6. Explanation says the first three pairs are returned from the sequence an array of integers 1 and 2, 1, 4, 1, 6, 7, 2, 7, 4, 11, 2, 7, 6, 11, 4, and 11, 6. So as you can see right here, they have sorted all of the possible pairs that we can create from these two arrays, right? From this array and this array. So first, they just matched all the ones. They took this one and matched it with all the elements in this array, right? That's how we got 1, 2 from this one and this 2. Then we got 1, 4 because this one and this 4. And then we got 1, 6 from this 1 and 1, 6 and this 6, right? So that's just the ones. That's all the pairs that we can create from this one. Then they did the same thing with the 7s. They took this 7 and did it with this 2 right here. Boom. Then they took the 7 and did 7, 4. Boom, right here. Then they took the 7 and did 7, 6. This 6 with the 7 right here. Then they did the same thing with the 11s. They did the 11, 11 and 2. Boom, from the 2 right here. Then they did 11, 4 and 11, 6 from the 4 and the 6 right here. Now, as you can see, they already sorted these in increasing order by sum. So as you can see, that's why this 11, 2 comes before this 7 and 6, because 11 plus 2 gives you 13, 7 plus 6 gives you 13. Well, I don't know why they did that, because they both 13s, but either way, these are the ones that we're worried about. These three right here are the smallest sums that we can create because we're just adding 1 to each of these instead of 7 to each of these or 11 to each of these. So that's why the output is the 1, 2, the 1, 4, and the 1, 6. That's where we got it from, because 1 plus 2 is 3, 1 plus 4 is 5, and 1 plus 6 is 7. We only need 3 pairs because k equals 3, and those are the 3 smallest sums that we can create. Everything else is going to be, all of these are going to, when you add them together, they're going to be more than 7, right? This would be 9, this would be 11, and so on. As you can see right here, these 3 go from 3, 5, and 7. That's why they are the smallest sum pairs, and that's why we return them right here, because we need 3 because k equals 3. So let's look at example 2, just in case you didn't really understand example 1. Principle pretty similar though, or pretty simple. So in example 2, we have the nums1 equals an array of integers 1, 1, and 2. Nums2 equals an array of integers 1, 2, and 3. This time k equals 2, so we only need to find two pairs of the smallest sum, right? It says right here in the explanation, the first 2 pairs are returned from the sequence 1, 1, from the sequence that they've given us, right? So this is just a sequence of all the possible pairs that can be created from these 2 arrays. And as you can see, we just took this one. We took We took this one and added it to this one. That's one pair. Then we took this one and added it to this one as well. And that's in second pair. They both equal 2. Both of these arrays equal 2, and as you can see, all of these arrays, if you add them together, they'll equal more than 2. Like this will equal 3, this will equal 3 as well, this will equal 3, and so on. They'll all equal 4. I mean, not 4, they all equal more than 2, but we want the smallest sum. These equals 2, and that's why 2 is the smallest sum, and these are the pairs that we need to get the smallest sum. So that's why the output is this 2D array of integers 1, 1, and 1, and 1, because we're just taking the smallest possible sum that we can create from one element from this array and one element from this array, and we want to return up to 2 pairs of the smallest possible sum that we can create. So now that we understand the solution, y'all, let's get into the fun part, the actual code. And guess what, y'all? This code it's gonna be fun. It's a nice little chunk of code. Like, so get ready, get prepared, because we have a lot of work to do with this code today. Now, first thing we need to do, we need to create our heap class. So in order to do that, we could just come right here and we could say public final class. We could call it heap. Excuse me, heap. Then we're going to say less than. We're going to put a T. Then we're going to say greater than. Or excuse me. Yeah. Then we're going to say colon. And then we're going to say custom string convertible. Custom string convertible, just like that. Now let's open up the bracket. Let's open up the brackets and let's get started. Now, first thing we need to do is we're gonna say public type alias. Then we're gonna say comparator, just like that. And we are going to say equals, it's going to be, open up the parentheses, we're going to say T, comma T, and we're going to set that equal to, or excuse me, and that's going to return a Boolean, just like that. Then we're going to come underneath that, and we are going to say private var elements equals, open up the square brackets, T, come outside the square brackets, put the parentheses. Then we're going to say private, another private var. This time we're going to say comparator again. This time, but lowercase c. Make sure the spelling's right. This time it's going to be lowercase c, and we are just going to cast that as the comparator that we have up here. Boom. Now we need to initialize an empty heap with a given comparator function. So in order to do that, we're just going to say public init, open up the parentheses, we're going to say with comparator colon, then we're going to say at escaping comparator with the capital C. Boom. Come outside of that, open up the brackets, we're going to say self.comparator lowercase c equals comparator lowercase c. Boom. Now we need to initialize a heap from an existing array and heapify it. So in order to do that, we're going to come outside of this public init. We're going to do another public init. This time we're going to open up the parentheses. We're going to say from array colon square bracket T, come outside of that, comma, with comparator colon at escaping, once again, capital C, comparator. Then we're going to come outside of that, open up the brackets. So open up the brackets, y'all. We're gonna say self dot elements equals array. Come underneath that, we're gonna say self dot comparator equals comparator, lowercase c, y'all. Then we need to convert the array into a valid heap using heapify. So a bottom up approach. So in order to do that, we're gonna open up the parentheses. We're gonna say 0 dot 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 array dot count divided by 2. Come outside of those parentheses, we're gonna say dot reversed, put the parentheses, dot reversed, make sure I spell that right, say dot for each, open up the brackets, we're gonna say in, or let me clean this up, I don't know why it looks like that. We'll come up here, we'll say in, then we'll come down here, and we'll say sift, S-I-F-T, open up the parentheses, down, colon, I. Boom. Now we need to make some public get properties. So in order to do that, we're going to come outside of this public init right here. We'll say public var root colon. We're going to say t question mark. Open up the brackets. We're going to say elements dot first. Excuse me. And that's going to return the top element of the heap. And then we're going to come down here and we're going to say public var is empty colon. That's going to be a bool. It's going to be space. That's going to be a bool. Open up the brackets. We're going to say elements. Excuse me. Elements dot is empty. And that is going to check if the heap is empty. Then we're going to come down here. We're going to say public var. We'll call this one size. Say colon. It's going to be an integer. Open up the brackets. We're going to say elements dot count. And that's going to get the number of elements in the heap. Now we need to create a function that's going to remove and return the top element. So in order to do that, we're going to come underneath this and we are going to say at this cardable, at this cardable result, public func, we'll call it poll, put a parentheses, is going to return t question mark, open up the brackets. We're going to say guard, exclamation point is empty, else, open up the brackets, we can return nil. Then we're going to come underneath that and we are going to say let polling element, excuse me, element, boom, sorry y'all, gotta make sure the spelling's right. Let polling element equal elements, open up the, excuse me, elements, open up the square bracket and put a 0 inside, boom. Now we need to replace the root with the last element and remove the last element. So in order to do that, come underneath that, we're going to say elements, square bracket 0, say equals elements, square bracket size minus 1. Boom. Then we're going to come underneath that, we're going to say elements dot remove last, parentheses. Now we need to restore the heap order from the root. So we're going to come right here. We're going to say sift, S-I-F-T, open up the parentheses, down, colon, 0. Come underneath that, and we are going to say return polling element, just like that. Now we need a new function that's going to insert a new element into the heap and maintain the heap order. So in order to do that, we're going to come underneath this right here, and we're going to say public func, call it insert, open up the parentheses, underscore element, colon, T, come outside the parentheses, open up the brackets. We'll say elements dot append, open up the parentheses and say element. Boom. Then we're going to come underneath that. We're going to say sift again, open up the parentheses. We're going to say up, colon, size, -1. Boom. Now, we're going to get into the private methods. We're not done yet. We still got more to go. So this is going to move an element up to the heap until the heap property is restored. Or up the heap, not up to the heap, but up the heap until the property is restored. So in order to do that, we're going to say private func sift, open up the parentheses. We're going to say up index, colon, it's going to be an integer. Come outside of that, open up the brackets. We're going to say declare a variable called I. We're going to set that equal to index. Come underneath that. And while the current node has a valid parent and violates heap property, then we're going to swap it. So we're going to say while comparator, open up the parentheses, element square bracket I, comma, elements square bracket I, or excuse me, square bracket, open up the parentheses, I -1. Excuse me, y'all. Come outside of those parentheses, and we're going to divide that by 2. Then we're going to come outside that last parentheses, and we're going to open up the brackets, and we're going to say elements dot swap at, open up the parentheses, I, comma, parentheses, I -1. Come outside those parentheses, and we're going to divide that by 2. Boom. Then we're going to come underneath that, and we're going to say I equals, open up the parentheses, I -1. Come outside of the parentheses and divide that by 2. Boom. Not done yet, because we still have more functions to write. So come outside this function, and this is going to move an element down the heap until the heap property is restored. So this time we're going to say private func sift, and this time we're going to say down index colon and come outside of that, open up the brackets, declare variable I, set that equal to index. We're going to say, so while the current node has at least one child, so we're going to say while 2 times I plus 1 is less than size, what we're going to do is we're going to open up the brackets, and we are going to say let left equal 2 times I plus 1. Then we're going to say let right equal, oh, excuse me, this should be 2 times I. Make sure I got these right. Oh, this right, you feel me? All right. So that should be 2 times I. Excuse me. 2, so we're going to say right, then we're going to say right equals 2 times I plus 2. Where the first one was plus 1, this is plus 2. Then we're going to come down here. We're going to declare a variable called J, set that equal to left. Then we are going to come right here, and if a child exists and is smaller than the left, we need to update J. So in order to do that, we're going to say if right is less than size, comma, comparator, open up the parentheses, elements, square bracket, right, come outside the square brackets, comma, elements, square bracket, left, come outside those parentheses, open up the bracket. We're going to say j equals right. Boom. Now, if the current node is smaller than both children, we're just going to break. So in order to do that, come outside this if statement, and we say if comparator, open up the parentheses, elements, square bracket I, comma, elements, square bracket j, then we're going to come outside of those parentheses, open up the bracket, and we're just going to say break. Boom. Now, we're going to say come outside of this if statement. And we need to swap the current node with the smallest child. So we'll say elements dot swap at, open up the parentheses, I, comma, j. Boom. And then we're going to continue sifting down at the new position. So we're just going to come underneath this and we're going to say I equals j. Boom. Then, it's not done yet, we're going to come right here, another public variable. So we're going to say public bar, call it description, colon, string, open up the brackets. We're going to say, use some string interpolation. So open up the quotation marks, say slash, open up the parentheses, elements, close the parentheses, just like that, right? So I know it's a lot, y'all. We're getting there. We still have more to go, though. We're just getting started. So now that we've created our heap class, let's go ahead and come up here and actually get started with the main function. Now, the main function, first thing we have to do is we're going to say let n equal nums1 dot count, comma, m is going to equal nums2 dot count. Boom, just like that. Now we need a set to keep track of visited index pairs to avoid duplicates. So we could just come right here and we're going to say var, declare variable called visited. We'll set that equal to a set. So set less than sign string greater than sign and put some parentheses at the end. Now we need a min heap to store the pairs in ascending order based off their sum. So we're going to say let heap equal heap. So let lowercase heap equal capital H heap, which is the heap class we just created. Then we're going to say less than, open up the square brackets, we're going to say int. Come outside those square brackets, put the greater than sign, open up the parentheses, we're going to say with, colon. Then we're going to open up the brackets, we're going to say $0, open up the square brackets, 2, come outside of that, we'll say it's less than $1, open up the square brackets, 2. Boom. Now we're going to come underneath that, and we need to start with the smallest possible pair, right? So we're going to say visited dot, let me make sure I spelled that right. Visited dot insert, open up the parentheses, quotation marks, we're just going to say 0.0. Then we're going to come underneath that, we're going to say heap dot insert. Then we're going to open up the parentheses, open up the square brackets, and we're going to say 0, 0, comma, nums1, square bracket 0, come outside of that square bracket, say plus nums2, square bracket 0. Boom, just like that. Now we're going to come underneath that, we're going to declare a variable called result, and we are going to set that equal to a 2D array of integers. We're just going to initialize it with some parentheses like this, and this result is what's going to store our output of 2D array output. Then we're going to come right here, we're going to declare another variable called k, and we're just going to set that equal to k. Boom. Now we need to process up to k elements or until the heap is empty. So in order to do that, we are going to say while k is greater than 0, comma, exclamation point, heap dot is empty. So while heap is not empty, that's what that means. We're going to say, first we need to get the smallest sum pair from the heap. So we're going to say let lm equal heap dot poll, parentheses, exclamation point. Then we're going to say result dot append, open up the parentheses. We're going to say square bracket nums1 square bracket. We are going to say lm square bracket again 0. And we're going to come outside of those two square brackets, still inside the other square bracket, and we are going to say, let me see, y'all, hold on, my bad. Yeah, we are going to say nums2, open up the square bracket, lm, open up the square bracket again, 1, just like that. Then we need to try adding the next element from nums1. So we're going to come underneath this. We're going to say if lm square bracket 0 plus 1 is less than n, comma, exclamation point, visited dot contains, open up the parentheses. We'll use some string interpolation. So open up the quotation marks, slash, open up the parentheses, lm square bracket 0, close the square bracket, plus 1. Then we are going to close the parentheses. Then we're going to say comma, and then we are going to say slash again, open up the parentheses, lm square bracket 1, and then we're going to close the parentheses. Boom. Then we're going to come outside of that, and we are going to, my bad, let me just make sure this is right. Then we're going to come outside of that, and we are going to open up the brackets. So let's open up the brackets. I'm trying to figure out why all this turned red. My bad, y'all. Oh, we didn't close the square bracket. We gotta close the square bracket right there. Boom. Okay. Now, let's keep going. So then we're gonna open up the brackets, and we are going to say visited dot insert, open up the parentheses, open up the quotation marks, slash, open up the parentheses, lm square bracket 0, close the square bracket, come outside the square bracket, close the square bracket, right? Okay, plus 1. Then we're going to come outside of these parentheses right here. And we are going to say, oh, hold on, y'all. So we're going to say, close the parentheses right here after the 1. Then we're going to say, comma, slash, open up the parentheses again, lm square bracket 1. Come outside of those parentheses. We still need to put the quotation marks. We need to close the quotation marks and put some more parentheses at the end. Then we're going to come underneath that, and we are going to say heap dot insert open up the parentheses, square bracket, lm, lm, square bracket 0, come outside the square bracket, and we're going to say plus 1. Then we'll say comma, lm, square bracket 1. Then we're going to come outside of that square bracket. We're going to say comma, nums 1, square bracket, lm, square bracket 0. Come outside that square bracket, we're going to say plus 1. Then we're going to come outside that plus 1 square bracket, and we're going to say plus nums 2 square bracket, lm, square bracket 1. Boom. Now, I know that was a lot. We're not done yet because we need to try adding the next element from nums 2. So in order to do that, we're going to come outside of this if statement, and we're going to say if lm, square bracket 1, plus, square, come outside of square brackets, and we'll say plus 1 is less than m, comma, exclamation point, visited dot contains, open up the parentheses, we're going to string interpolation, so then we're going to say slash, open up the parentheses. I don't know why it only opens up one parenthesis and you have to close it yourself, so let's just do that first. Close the parentheses first. Come inside, we're going to say lm, square bracket 0. Then we're going to come outside of that parentheses right there, the blue parentheses right there. We're going to say comma, slash, open up the parentheses, close them again just like that. And this time we're going to say inside of these parentheses, say lm, square bracket 1. Come outside those square brackets, we're going to say plus 1. Then we're going to come outside of all those parentheses and open up the brackets. And we are going to say visited dot insert, open up the parentheses again. We've got more string interpolation, so open up the quotation marks. Then we're going to say slash, open up the parentheses. We are going to say lm, square bracket 0. Come outside those parentheses, the inside parentheses. We'll say comma, slash, open up the parentheses again. Come inside those parentheses, we're going to say lm, square bracket 1, plus 1. Boom. Then we're going to come underneath that, and we are going to say heap dot insert. Then we are going to open up the parentheses, open up the square brackets. We're going to say lm, square bracket 0, come outside of the square bracket, comma, lm, square bracket 1, come outside this, come outside those square brackets, say plus 1. Then we're going to say comma, then we'll say nums 1, square bracket, lm, square bracket 0. Come outside these two square brackets, we're going to say plus nums 2, square bracket, lm, square bracket 1. Come outside that square bracket, we're going to say plus 1. Boom. Then we are going to come right here underneath this, and we are going to say k minus equals 1. And then we're going to come underneath that, and we are going to say, hold on, y'all. My bad, y'all. I think I messed up somewhere, but we'll see after. We're going to come right here, come underneath that, come right here. We're going to say return result. Now let's run it. I think it's an error somewhere. So let's see. What is the error? Hold on now. Let me see. My bad, y'all. Let me see, y'all. Let me see. I think, hopefully, this should be its own separate class. So hopefully, I put it all in the same class when I shouldn't have. It should be two separate classes. This should be a class, and this should be a class. So now, let's see, it says expected keyword FAANG. So my bad, y'all. So that has to be a public alias. We have final class, public. What I do, it says final class here, expected. So let's see, y'all. Let's see. Make sure I spelled it right. Oh, excuse me. Type alias. It should be a type. Should be like that. Now let's run it. Okay, now let's see where the error is at. Okay, so right here, what we do wrong here. Oh, equal white space, boom. So let's run it again. Let's see. And it's accepted, y'all. That's what I'm talking about. I know that was a lot of code, but we got through it. We stayed determined. We kept going. We pushed through, and it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it, because we all know how LeetCode can get. You never know. Get rid of that, and look at that, y'all. 103 milliseconds beats 26.92% of users with Swift. I know it was a lot today. So before we leave, make sure to get one more look at the code. So this is, if you need this, get a look at it. Boom. Then if you need this, get a look at it. Boom. Then if you need this, go ahead, read it, learn it, love it. Yeah, this was a lot of code today, y'all. But we got through it. Give yourself a pat on the back. Go ahead and look at this if you need it. Then that's the end right here. Boom. Get a look at it. Get a good look. Now we're going to check out the main function. So get a look at the main function. Make sure you get all this good code, y'all. This was a lot. I hope y'all learned something today. All this code, we just typed. Whole lot of stuff to learn, y'all. Whole lot of stuff, whole lot of math. I was worried about the math because you already know you get the math wrong answer, and it ain't going to tell you where you messed up in the math. So I'm glad we got through with that. Now, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.